Good day all of you. Today in this video I am going to solve some problems on operations on random variables. Operations on random variables. These are very important problems and all these are given in some university examinations. Consider the first problem. Consider a random variable x with the probability mass function as given. This is the information about the probability mass function. You have to find mean of x and second variance of x. Let us see the solution. Mean of x is represented by x bar. What is x bar? The other notation is m1. You can also call it as expectation of x. The problem is about the discrete random variable. So what is E of x formula? I is from 1 to n xi into p of xi. That is the formula. Here xi's are values of the random variable and p of xi are the probabilities of those random values. Okay. So here how many random variables are given? 4. Therefore, your mean x bar is equal to sigma I is from 1 to 4 xi into p of xi. So simply, 0. Xi here is 0 into 1 by 8. Next, 1 into 1 by 8 plus 2 into 1 by 4 plus 3 into 1 by 2. Okay. The answer is 2.125. So this is the mean value of x. Variance of x is represented by sigma x square. What is the formula? Sigma x square is equal to, the other notation is mu2 is E of x minus x bar whole square. What is the formula in discrete case? I is from 1 to n. Xi minus x bar whole square into p of xi. Then if you substitute, implies your variance sigma x square is, substitute all the values and x bar. 0 minus, here the minus 2.125, x bar is 2.125. 2.125 whole square into p of xi is 1 by 8 plus 1 minus 2.125 whole square into 1 by 8 plus 2 minus 2.125 whole square into 1 by 4 plus 3 minus 2.125 whole square into 1 by 2. So that is the expansion of your sigma x square. You're going to get the answer as 1.1093. Okay, so this is the way of finding mean of x and variance of x for a discrete random variable for the given probability mass function. Second question. Show that expectation of C1 into H1 of x plus C2 into H2 of x is equal to C1 into expectation of H1 of x plus C2 into expectation of H2 of x, where H1 of x and H2 of x are random variables. I'll say the solution. We know from the expectation of function of random variables concept, that is E of g of x. Normally expectation of x means u of x. Expectation of function of random variable means u of g of x, where g of x is function of random variable. What is the formula? Integral minus infinity to infinite g of x into fx of x dx. Okay. Now we'll use this concept. So now what is g of x here? G of x is now this one. Therefore, just substitute that C1 into H1 of x plus C2 into H2 of x is equal to, yes, just substitute g of x here. C1 into H1 of x plus C2 into H2 of x, okay, into fx of x dx. You can separate the integration. Therefore, you're going to get integral minus infinity to infinite C1 into H1 of x into fx of x dx plus integral minus infinity to infinite C2 into H2 of x into fx of x dx. So it is simply C1 integral minus infinity to infinite H1 of x into fx of x dx plus C2 into integral minus infinity to infinite H2 of x into fx of x dx. So it's nothing but C1 into, what is this? This is nothing but expectation of the function h1 of x. Therefore, E of h1 of x plus, what is this? C2 into, this is the expectation of h2 of x. Okay, so hence proved. Therefore, expectation of C1 into h1 of x plus C2 into h2 of x is equal to C1 into expectation of h1 of x plus C2 into expectation of h2 of x. That's all. This is proved. The next question. A random variable is uniformly distributed over the interval 0, 1. Find the PDF of new random variable y equal to x square. Yeah. First, what is the random variable? X is the random variable and it is uniformly distributed. So, x is, the random variable x is uniformly distributed over 0, 1. Given the new random variable y equal to x square, you have to find PDF, probability distribution function of the new random variable fy of y. So now see carefully. From the definition of probability distribution function, fy of y is probability of y less than or equal to small y. Then how to write this y? As y is x square, you can write x square less than or equal to y. That is equal to p of simply, yes, write x here, so it becomes root y. So x less than or equal to root y. So now you can write it as fx of root y. What is the reason? Actually, what is p of x less than or equal to x? It is fx of x. This is the definition of probability distribution function. So fx of root y is nothing but your fy of y. Okay. So now how to find fx of root y? So see the given problem. The random variable is uniformly distributed. Okay. So what is the density function of a uniformly distributed random variable? Fx of x is equal to 1 by b minus a between the limits and 0 otherwise. But for us, what are the limits? The limits are 0 and 1. So what is fx of x? Fx of x is here a is 0, b is 1. So it is 1 for 0 less than or equal to x less than or equal to 1 and 0 otherwise for our given range. Okay, so this is probability density function, and we know the probability distribution function is the integration of fx of x. So if you integrate it, you're going to get x between the limits, and for less than 0 we know it is 0, and for greater than 1 it is 1. So it will be, see, this is the density function and this is the distribution function. Okay. So what is this? This is fx of x. Now what is fx of root y? Which is nothing but our fy of y. Simply, here it is fx of x. Distribution function of the random variable x is x 0 1. This 0 is for x less than 0 and 1 is for x greater than 1. So now in the place of x you simply substitute root y. That's all. So it is, so in the place of x you simply substitute root y. That's all. So root y in the limits 0 less than or equal to root y less than or equal to 1. 0 for root y less than 0 and 1 for for root y greater than 0. Sorry, root y for 1. Root y greater than 1. This is your fy of y. That's all. Then, what is the density function? Simply it is d by dy of fy of y. D by dy of root y is 1 by 2 root y between the limits 0 less than y less than 1 and 0 otherwise. So if you see here, it is fx of root y, that is the reason of taking the limits with respect to root y. Here it is fy of y, that is the reason of taking the limits or the range with respect to y. Okay, so this is the way of finding probability distribution function of a new random variable y equal to x square if the given random variable is uniformly distributed. Okay. Now consider the next problem. Consider a random variable with the PDF, means the probability density function, fx of x is equal to 1 by 6x between the limits 2 less than or equal to x less than or equal to 4 and 0 otherwise. We have to find e of x and second e of x square and third sigma, which is nothing but standard deviation. Then I'll see the first one, e of x, which is nothing but x bar is, general formula is integral minus infinity to infinite x into fx of x dx. So now it is, our limits are 2 to 4, x into 1 by 6x dx. Nothing but 2 to 4 x square by 6 dx is x cube by 18 between the limits 2 to 4, nothing but your 28 by 9. Second one, e of x square, formula is integral minus infinity to infinite x square into fx of x dx. That is integral 2 to 4 x square into 1 by 6x dx. Integral 2 to 4 x cube by 6 dx. The value is 10. If we solve it, then you'll get 10. Then the third one, sigma means the standard deviation. To find the standard deviation, first you have to find the variance, sigma x square variance. After this, to find sigma, simply go for sigma x square. Then how to find sigma x square or variance of x? E of x minus x bar square, nothing but minus infinity to infinite x minus x bar whole square fx of x dx. Then for us the limits are 2 to 4. Okay, x minus, what is x bar? 28 by 9 whole square, and what is our fx of x? It is 1 by 6x dx. So if you solve this, then you're going to get 26 by 81 as your variance. Therefore, now the next problem. A random variable x takes the values -4, -1, 2, 3, 4. Each with probability 1/5. Find density function, the mean, and variance of the random variable y equal to 3x square. We'll form a table for the given random variable values and the probability. X, p of x, -4, -1, 2, 3 and 4. All the probabilities are 1/5. Then first you'll see the density function. Fx of x. Formula is sigma I is from 1 to n p of xi into delta of x minus xi. This is the general formula. For us the formula is I is from 1 to 5 as the number of random values are 5. P of xi into delta of x minus xi. So now we'll expand. P of xi for I is 1 is 1/5. Delta of x minus, what is xi? It is -4. So now if you substitute -4 here, it will become +4. Next, 1/5 delta of x plus 1. 1/5 delta of x minus 2. 1/5 delta of x minus 3 plus 1/5 delta of x minus 4. So this is the density function. Okay. Then I'll find the mean. Mean m1 or x bar, or you can call it as E of x, is sigma I is from 1 to n xi into p of xi. So for us, m1 is I is from 1 to 5 xi into p of xi. Yes, xi, first xi is -4 into the corresponding probability is 1/5 plus -1 into 1/5 plus 2 into 1/5 plus 3 into 1/5 plus 4 into 1/5. Okay, so if we solve this, the answer is 4/5. Then what is the third thing that we have to find? The new random variable is y equal to x square. Okay, you have to find variance. Small correction, the new random variable is y equal to 3x square. So now y equal to 3x square, consider y equal to 3x square as the new random variable. Now observe the procedure carefully. Whenever you're given the new random variable in terms of the past random variable, and if they ask any variance or mean or something skew like that, you have to go like this. The corresponding values of y for each x. How to calculate? Simply, what is x? I'll make you remember. -4 -1 2 3 and 4. This is x. So now what is y? Just apply this. Okay, x square is -4 square into 3. So it is 48. Then -1 square, 1 into 3, 3. Like that, if you calculate, you'll get 48, 3, 12, 27, 48. Okay, then this is the new random variable. This is the old random variable and this is the new random variable. Then we have to find probabilities of the new random variable y. How to find? If you see 48, the first random variable value 48, and the last random variable value means the value of the random variable is also 48. So what is the meaning? Here in x -4 and this 4 are mapped to the y 48 and 48. So in this case you have to find probability of y is equal to 48 is probability of x is equal to -4 plus probability of x is equal to 4. Like this you have to find. What is probability of x is equal to -4? We all know all the events probabilities are 1 by 5. So it is 1 by 5 and it is 1 by 5. So it is 2 by 5. The values 3, 12, 27 are mapped to -1, 2, 3 respectively. Okay. So totally, if you form a table for the new random variable y, this is y and this is p of y. So what are the values here? Actually we have 5, but as these two are same, you can write 48, 3, 12 and 27. Because there exists high probability for 48 because it appears twice and we calculated it also. So totally 48, 3, 12 and 27. What is the probability for 48? 2 by 5. And what is the probability of 3? As 3 is mapped to -1. What is the probability of -1? 1 by 5. And here 12 is mapped to 2. The probability is 1 by 5. 27 is mapped to 3. The probability is 1 by 5. So this is the new random variable y and its probability. Now for this, you have to find the variance. What is the variance? What is the formula for variance? Variance of y is equal to E of y minus y bar square. Okay. Then to find this, what first you need? You need y bar. Y bar means mean. Mean. You all know the formula. Sigma I is from 1 to n xi into p of xi. This is the new random variable. So it is sigma I is from 1 to n yi into p of yi. Here the y values are 4. So I is from 1 to 4. Yi into p of yi. So it is 48 into 2 by 5 plus 3 into 1 by 5 plus 12 into 1 by 5 plus 27 into 1 by 5. Answer is 27.6. Okay, then now you find E of y minus y bar square. The formula is sigma I is from again 1 to 4 yi minus y bar square into p of yi. So it is sigma I is from 1 to 4. What is yi has 4 values, but y bar is 27.6 square into p of yi. So it is 48 minus 27.6 whole square into 2 by 5 plus 3 minus 27.6 whole square into 1 by 5 plus 12 minus 27.6 whole square into 1 by 5 plus 27 minus 27.6 whole square into 1 by 5. The answer is 364.56. So this is the way of finding variance for the new random variable y is equal to 3x square. The next problem is find the characteristic function of a random variable with fx of x is equal to lambda into e power minus lambda x u of x, where lambda is greater than 0. And we know the characteristic function formula, phi x of omega equal to expectation of e power j omega x. Simply write the equation. Okay, integral minus infinity to infinite, expectation of e power j omega x. So you have to write e power j omega x here into fx of x dx. Simply you substitute the given fx of x dx here. As it is u of x, means your random variable exists only for positive portion. That is the reason it has given greater than 0. So the limits becomes integral 0 to infinite. So just it is e power j omega x, e power minus lambda x. Lambda is constant now. So simply take e power j omega minus lambda of x. Just you do the integration. Substitute the limits like this. You are going to get the answer lambda by lambda minus j omega. Problem is characteristic function of a random variable is given by phi x of omega equal to 1 by 1 minus j omega. Find the mean value of x, the variance of x. See here, what is phi x of omega? It is 1 by 1 minus j omega. Yes, first you have to find the mean value of x. From the concept of characteristic function, the nth moment formula is like this. Mn equal to, nth moment Mn equal to minus j power n d power n by d omega power n of phi x of omega at omega equal to 0. Okay, so this is the nth moment. According to this, if you want to find the mean value, n becomes 1. So if you keep n 1, m1 equal to minus j into d by d omega of 1 by 1 minus j omega at omega equal to 0. So simply do the differentiation. You are going to get the answer as 1. Next, variance of x. Variance of x is sigma x square. From the concept of characteristic function, we can't find the variance of x directly. But we have a relation between the variance of x and the moments m. And here, see here, the variance is, you can find this with the help of the concept moments about mean. And these m's are moments about origin. So this is the relation between moments about mean and moments about origin. So with this expression, you can find the variance. For this, we already find m1. m1, we got it as 1. And now we have to find m2. According to the nth moment formula, m2 equal to minus j square d square by d omega square of 1 minus 1 minus d square by d omega square of 1 by 1 minus j omega at omega equal to 0. Simply you have to do double time differentiation of this. So if you do this, yes, here I have differentiated for single time first and then again I differentiated and I got the answer m2 as 2. So what is the variance now? Now substitute the m2 value and m1 value here. m2 is 2 and m1 is 1. So it is simply 2 minus 1 square, which is 2 minus 1 is nothing but the answer is plus 1. Okay. Then the next problem. This is the problem. A Gaussian random variable with variance 10 and mean 5 is transformed to y equal to e power x. find the probability density function of y. Okay. Yes, the random variable x is transformed to y equal to e power x. Now, see here. What is the PDF of the Gaussian random variable x? We know the formula. Fx of x is equal to 1 by 2 pi root x square. Okay. Exponential of minus of x minus mu x whole square by 2 sigma x square is the fixed formula for Gaussian random variable. Okay. So, given the variance of sigma x square, that is 10, and the mean mu x as 5. Simply you substitute 10 and 5 in this expression. You are going to get this. Now take the given transformation. What is the given transformation? What is the given transformation? Y equal to e power x. Simply you apply ln on both sides. So it becomes x is equal to ln of y. So now you do dx is equal to 1 by y dy. Just apply differentiation on both sides. Okay. You got dx by dy as 1 by y. What is the reason of this? This is the relation for the new random variable density function and the old random variable density function. Okay. And they asked the density function of y if y equal to e power x. Yes, as this is the relation between the new random variable and the old random variable densities functions for monotonic transformation case, you have to find dx by dy. That is the reason of finding dx by dy here. We got dx by dy as 1 by y. Okay. So simply substitute dx by dy as 1 by y and fx of x. Fx of x is already we derived. Just substitute here fx of x for the given variance and given mean. So you're going to get this fi of y.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.